Hey everyone, let's get right into it. Today, we are taking a direct, hands-on look at exactly how to calculate and report energy management performance for the processed foods industry. Think of this explainer as your ultimate tutorial. We're going to break down the SASB standard step by step so you can get your energy data perfectly aligned, incredibly accurate, and totally ready for the real world.
So, the absolute crucial point we're starting with is this. How do you genuinely, accurately measure energy management in the processed foods industry? It sounds like a really straightforward question on the surface, but man, once you get into the weeds of managing multiple facilities, calculating different fuel types, and balancing a mix of grid and renewable power, the math gets a bit complex, right? Well, that's exactly why we're here. We are going to solve this exact problem together, focusing specifically on reporting total energy consumed in gigajoules, alongside your percentages of grid electricity and renewable energy. That way, you can report your numbers with absolute confidence.
I want to ground our discussion right in the source material itself. The SASB standard explicitly notes, the processed foods industry is reliant on energy and fuel as primary inputs for value creation. We aren't just talking about, keeping the overhead lights on in a corporate office building. We are talking about massive manufacturing facilities required to literally cook, refrigerate, and package the entire world's food supply. Getting this metric right, it isn't just some basic compliance checkbox. It's absolutely crucial for protecting your bottom line from highly volatile fossil fuel costs.
Okay, let's dive into this. Here is our syllabus for today's masterclass. First, why energy management matters. Second, the core energy metric. Third, calculating total energy consumed. Fourth, measuring grid electricity percentage. Fifth, reporting renewable energy accurately. And finally, conversions and final rules.
All right, Section 1. Why energy management matters, financial and climate risks.
Listen, the food processing industry has a massive, and I mean massive, energy footprint. You're operating heavy-duty cooking equipment, you're keeping giant warehouses refrigerated to exact, precise degrees, and you're running these continuous packaging lines. It is an incredibly energy-dense process, and this creates a major dual threat. First, you've got a severe financial risk from volatile energy costs, especially natural gas, which this sector leans on heavily. Second, you have a huge environmental risk regarding your direct and indirect greenhouse gas emissions. Measuring your energy usage properly is the only way to mitigate these risks, whether that's shifting to alternative fuels, bringing in renewables, or even setting up your own on-site generation. Ultimately, you just can't manage what you don't measure.
Moving on to Section 2, the core energy metric, SASB FB PF 130A.1.
So, this overarching metric requires you to report your energy management performance in three very distinct components. It's basically a three-part harmony. First, you need the absolute total of energy consumed, and this must be reported in gigajoules. Second, you have to report what percentage of that total came from standard grid electricity, and third, what percentage came from renewable energy. By the end of this explainer, you are going to know exactly how to calculate all three.
Which brings us to Section 3, total energy consumed, calculating the baseline.
First things first, to get this right, you've got to capture the absolute total of the energy you used. Total energy literally means everything. It includes all the energy you purchased from external sources, plus all the energy you generated yourself. We're talking direct fuel usage, purchased electricity, heating, cooling, steam, the whole shebang. But actually, there is a critical qualifier here. It only includes energy that was directly consumed by your entity during the specific reporting period. So you aren't counting fuel just sitting unused in a storage tank. You are only counting what was actually burned or consumed. Now, when calculating the energy you get from burning fuels and biofuels, the SASB standard gives us a very specific rule. You absolutely must use higher heating values, or HHVs. Sometimes people call these gross calorific values. You can measure this directly yourself, or you can pull the data from the Intergovernmental Panel on Climate Change, the IPCC. But what you cannot do is just guess how much energy a ton of coal or a gallon of diesel gave you. No matter how good you think your napkin math is, there's no way. You must use the formal HHV standard to convert that raw fuel into a completely accurate energy measurement.
Okay, Section 4, grid electricity, measuring grid reliance.
And this brilliantly illustrates the next concept. We are essentially taking that massive total energy footprint we just calculated, and we're slicing it up like a giant pie. We want to know exactly how much of your total pie is reliant on the standard public power grid, because that grid reliance represents a very specific type of cost and emissions profile that your investors care deeply about. The actual math here is incredibly straightforward, but the precision is what matters. Step 1.
Identify all of your purchased grid electricity consumption. Step 2, just divide that number by the total energy consumption we calculated back in Part 1. Boom, that gives you your grid electricity percentage. It's a simple ratio for sure, but it powerfully reveals just how dependent your facilities are on external utility companies versus your own internal generation.
Moving right along to Section 5, Renewable Energy, Reporting Accurately.
So first, we really need to establish the baseline definition. What actually qualifies as renewable energy under this standard? Well, it's strictly defined as energy from sources that are replenished at a rate greater than or equal to their rate of depletion. The classic examples all apply here, right? Geothermal, wind, solar, hydroelectricity, and biomass.
Now, what's really interesting about this next point is that it busts a major myth in corporate reporting. A lot of companies think, hey, my local power grid uses 20% wind power, so I get to claim that 20% on my own sustainability report. Nope. Under SASB rules, you absolutely cannot count the renewable portion of the electricity grid mix that is outside of your control. You can only count renewables that you directly produced or that you purchased through specific structured agreements, like power purchase agreements, where you explicitly retain and retire the renewable energy certificates, or RECs. If you sell that certificate, you sell the right to claim the green energy. It really is that simple. And let's look at how this applies when we talk about biomass. Because biomass literally involves burning organic material, the rules here are incredibly strict to prevent deforestation under the guise of green energy. To claim biomass as renewable under this metric, the materials must be certified to a verified third-party standard. We are talking about heavy hitters here, like the Forest Stewardship Council, the Sustainable Forest Initiative, or materials eligible under the Green E framework. You have to prove without a doubt that your biomass is sustainably sourced.
So once you've gone through and filtered out all the energy that doesn't meet those strict requirements, the math is just like the grid electricity step. You sum up all your verified renewable consumption, both what you produced on site and what you purchased with retained certificates. Then you simply divide that by your total energy consumption. And there you go. Now you have a rock-solid, fully audit-ready renewable energy percentage.
Finally, Section 6, Conversions and Final Rules, Ensuring Data Integrity. Look, the absolute golden rule of reporting this metric is consistency. You might have facilities pulling data from all over the world, right? Some are measuring in therms, some in BTUs, some in kilowatt hours. You must apply conversion factors consistently across all your data sets. As we discussed earlier, always use higher heating values for your fuel. And crucially, make absolutely sure you convert all those kilowatt hours generated by your solar panels or wind turbines into gigajoules. Every single number in your final equation has to map back to that one single unit of measure, the gigajoule. Which brings us to a final thought for you to chew on. Once you have actually done this math and you see your company's true energy footprint laid bare, the total volume in gigajoules, your exact grid reliance, your verified renewables, ask yourself, how will this transparent reporting transform your exposure to volatile fossil fuel costs and climate risks? Because honestly, this isn't just some accounting exercise for a sustainability report. This data is a powerful, strategic tool for future-proofing your entire food processing business. Thanks so much for joining me for this explainer, and I really hope you feel totally empowered to tackle your energy metrics head-on.